Hello everyone, so I'm Sam from E3D, I'm one of the principal design engineers here, and I'm this Julian, the CEO and co-founder of Batch.Works.
Step voicing our feedback. The way it's a slide split. Just there.
Yeah?
See your feedback. There it is.
Pretty happy? Perfect. So we've got a little bit of a talk today about a project we've been having.
Feedback again. That's gone. There it is.
About a project we've been working on together for the past year or so, and that is about 3D printed print farms. So let's quick overview of what we're going to talk through today. Quick summary of the project background, a few use cases that we have, and then we're going to get into some stuff about the printed design itself, and then a little demo of the automation aspect of it. If you have any questions, we do have a slide at the end, but the ad hoc questions are also okay. So we'll just kick straight after it.
Cool. So this project came about a year ago. So I'm going to give you a bit more background about Batch.Works, who we are. I'm sure a lot of people know about E3D. So we are a print farm. I've been in 3D printing for the last 15 years. And we've been working with brands and B2B business to print things for quite a long time. So we have a fleet of about 100 machines in East London. We've been quite hidden from the whole 3D printing scene, I would say. We've been working with clients like Marks & Spencer and other furniture companies to actually make products and end-use products. So we've been, over the last 3-4 years, we've received quite a significant amount of money from Innovate UK to actually scale this technology. I think one of the things that 3D printing has overpromised 15, 20 years ago is now happening. 3D printing is scaling, applications are now there. Enterprise companies are now using it, but the majority of the printers are still consumer, sort of desktop machines. And so we partnered with E3D. So our expertise in obviously running the farm, but also our background is design, industrial design, architecture, and so really working with the client on what a 3D printed product is. And then with the engineering and expertise of E3D, we came together to essentially build what we think is the most optimal farm system out there if we want to scale to thousands and thousands of machines. So the vision of Batch.Works is to build farms all over the globe, giving access to brands and individuals, scalable and affordable way to print things. And another aspect of the company is the circularity and sustainability. So we work with 3QF in the UK, but also in the EU for recycled materials. So one of the core of our company as well is using exclusively recycled material. So we've been working hard over the last few years to have a full circular loop of recycling material. And today we're super excited to share this new venture with E3D, which is kind of a dream come true, I would say, of a 3D printer, right? So that's not a new idea, but that's something we want to scale. For us, there was no point of trying to do one thing of the company where we change the way products are made, to the end customer, and still using a traditional way of making the hardware. So we made the hardware and the printer is the same way some of our products are for the end clients. One of our hero projects, which was on Dragon's Den last week, is Kibu. So it's the first kids headphones that you can build, repair, and recycle. It comes as a kit, and for us, that's one of our vertical in consumer electronics. And I think that's a great way to incentivize, the youngers, the next generation to understand what, what consumer product, consumer electronics is, and what can actually value materials and how it can be used. We can the other piece of the company, so we discussed about hardware and material and circularity. The other one is software, which is key to the ecosystem. So we've built three platforms. So there's a sales and ordering platform for the clients. There's a design and products management platform, and there's a factory manager. And essentially that allow us in a very inconsistent way and very sort of tied up system, we can actually have a proper flow around ideation of the product, slicing, printing in one platform and monitoring and feeding back the information to different stages of the design and manufacturing process. Because at the moment you still need, there are a bunch of platforms you need to use to actually to make that work. And the traceability and end of life of the product, be able to scan the product, knowing where it's coming from, what's the material. That's something that is very important to us. And so the software has all of those capabilities built in. And that we believe that what's going to make a successful farm. At the moment, there are a bunch of bottlenecks. Automation is one, material is another one, which Sam will talk about it. And then so it's about tackling all those elements to actually have the system that works. It's fine to have 500 or 1,000 machines on the shelf, but you're creating so much friction as you scale. Material, maintenance of the printers. That's what makes a 3D printing farm not being able to scale beyond, a couple of hundred of machines. And so the way we see it is really using how data centers works, using server racks and scalable systems already out there, and actually design a machine fit for purpose. So it fits to what is actually going to make to the client rather than a printer that can kind of make a bit of everything. So yeah, that's the background. So in use cases, so we really focus on the end consumer products. We make things that people use, we make things that companies want, and sometimes it's not the most interesting thing. We've made about 110,000 units for Marks & Spencer. So if you walk into any Marks & Spencer's that has the beauty sectors, all their pricing tags are 3D printed. We also work with Period Care Company. It's quite an interesting market. If you where it's pretty simple, basic dispensers. We actually make them customized to the brand and colorful, which something that was not possible before. And we're changing the status quo of what this market was. The headphones, which is there, I usually bring them with me. I forgot to take them with me. Shame. Bene, which is a furniture company in Europe. So we manage over 4,000 different SKUs at all time on our warehouse, and clients can order any minimum order quantity, and we work with them right from the ideation design stage all the way to the delivery of the product. And I think that's where it's key, is that we bring the expertise of right from what the customer wants rather than someone just dropping in STL files, which is usually 99% of the time is not optimized for 3D printing. So
I'll share. So hopefully that's given you a good background to Batch.Works on the project and some where the goals for this are going. Now we're going to dig into, I guess, the bit that's quite appropriate for the show, being with the RepRap history, but this is the printer that we have come up with. So the main features around this is it's a correct time machine with a surprisingly small build volume for what you might expect from a print farm, but this actually covers most of the use cases for the products that we're trying to make with this. But we have tried to make the design scalable, so there is a larger format printer that's being worked on at the moment. There are options for us, but this is sort of like where we're starting. Another thing is that when people usually think of a fully printed 3D printer, they think, it's not good quality, you're not going to get good specs out of it. However, that isn't the case with this. So in terms of performance characteristics, it's up there with sort of like the state-of-the-art ones that you see at the moment. So it can get to 0.5 meter a second at high speeds and up to 20k pixels, which is obviously crazy fast for something that is fully 3D printed. In terms of how we've gone about that design and like why we've chosen to do that, it gives us complete design freedom. We all know and love the use case of 3D printing, that you can make anything you need. You can create geometries and stuff that aren't manufacturable in other technologies. And so use that to our advantage. As E3D, we've done that a few times in the past, like with the 3D printed heatsink rotors and stuff like that. But now we're turning that into the machine itself. It also means it's very good to scale on demand. It's not a case you need to like wait for a big order for machined parts or injection molded parts. We have printers and print farms. We can scale on demand for when orders increase. But not only that, as Julian mentioned, do a lot about the like recyclability. And so using the existing supply chain that they already have at the end of life, or if we decide to make the printer design a Rev 2 when we want to swap parts out, and we can break it down, remove all the mechanical components that are still functional, bolt them to a brand new frame, and then the old frame can get sent off for recycling, turned back into filament, and so that like recycle can continue that way.
You can tie it in there.
So
Have lost watch out there inside, so that's protection, cost protection.
Yeah, so and with that, one thing that E3D's been pushing a lot historically is you use the right nozzle for the right job, and whether that be abrasion resistant, high flow, or nozzle size. And again, we've carried those learnings into this, and so different aspects of the printer are printed differently, which is sort of sounds fairly obvious when you say it, but rather than just using a 0.4 nozzle for everything, it's used for the smaller detail bits. The sort of like top gantry is printed in a more traditional method, i.e. you've got top molds, premises, and infill, and increasing those to get more structural rigidity from it. But we do that with a 0.6 nozzle. It still gives us our fine detail resolution for trying to get small features into there. So yeah, this top half is printed with that method. It's all printed in ABS-GF, which has got us very good performance in terms of mechanical properties.
So you can start.
Thank you. And then we've used the same material, but very different methods for the frame. And this is one that's actually quite exciting. So this is done in something like a single perimeter style. So this is something with Batch.Works I've got a lot of experience with. They do a lot of their products this way, and so they brought that learning into it. And so this frame is not only the frame, but it's the entire like Z-axis as well. So this is printed with a big 1.2 millimeter nozzle, which means we get nice, thick, strong perimeters. And then all that sort of like ribbing that you can see of those internal structures, that gives it its rigidity and sort of essentially counteracts the fact that it's not printed with infill. But the benefit is that this is printed in, I think, about 4.5 hours, compared to if you tried to load the same file with a normal nozzle, it'd be a few days worth of printing. So again, on scaling the print farm, you try to bring this time down for making the printer itself, which you can scale quicker. Yeah, on the so also, and then on the tool head design, so we've taken a few of the E3D products and also introduced a new one into this. So the bottom left image is our Revo high flow. So it's the high flow technology where it splits the flow into multiple channels to increase the surface area and the heat that's transferred into the filament. Again, with the print farms, you kind of want to be making the prints as efficiently as possible, so that is increasing the flow rate of them. On the extruder side, we've got a custom tool head, but it uses the rotary vitamins, which is essentially the motor and gears drivetrain from the rotary extruder. That is super light, which are also super small, which is beneficial for these nice, tightly compact printers, because obviously you want to try and get the most build volume out of your printer volume, so that you can fit the most machines in. And also with it being lighter, that's helped enable us do this fully printed design. And then the other new one is a strain gauge or load cell heatsink design, which is up in the top right. So this is essentially like a development on from our piezo, so it does nozzle contact probing. But the beauty of the strain gauge is that you have a lot more control over it, and you can get a lot more data out of it, which means that the signal that it's registering, you can sort of remove false triggers, and it can detect if there's filament still on the nozzle when you're trying to probe. And so then it knows what state it's in, and so then it can correct for it. Again, if you're trying to like run lights out, run these for like a few days straight without having to intervene, the printer needs to know when it's homed it correctly. It needs to know when the filament's run out. So all of those sensors and things like that have to be added onto it so that it stops when something's gone wrong and a human can come and intervene with it. Otherwise, it just keeps on going. And then stop thank you. So this is a video. You have to make that work. So this is a little video of what we have on the stand at the moment. So this is a little demo rack. It's just a 2-printer rack. On a full-size server rack, we get 6 printers in there. And this is one of the ways in which you can remove the part from the printer. This is one of the M&S pricing clips that we mentioned earlier. Because this is quite a small part, a low contact area with the beds, is it? You'll have to come to the stand. The video's not working. It'll be fine.
Teasing.
Yeah, here's a picture of something that does, I promise you, moves. So essentially the way that this one works is once the printer's finished, it does a bit like nozzle cleaning, and then the bed lifts up, and then you can see that there's like a ramp on the front of the printer, and essentially that's designed in to guide the parts into the tray where they collect, and then the bar comes along and knocks it off. So that's obviously quite on the more simple side of part removal, but there is another method that we have that essentially has a hook that hooks onto the back of the build plate, and then the build plate drops down and it flexes it, and then we have on either side of the printer there's a 100mm auxiliary fans, so you get a lot of cooling there, and that can just fire air out that to help rapidly cool it down. Again, with trying to optimize your print farm, you want everything to be as fast as possible. So the time you could go from print end to part removal, you want to get that as small as possible. And so it'll flex it, and then it will lift it up and do the same part removal. And because we're looking at doing orders that are in the thousands, tens of thousands, it means that we can create little custom like grabbers and pushers and things like that for the part itself. And there's a bunch of attachment points on the tool head. It's just a couple of bolts, clamp that on, and then your printer's ready to go in that new configuration. And once the order's done, the operator can take that off, put a different one in if required, and then the next order's going. How does the video of me in real life at the stand? I'm sure I should come back and look at that. Yes, I think that. I think that takes us to the questions. Straight away.
So you're printing the flame printer, which is obviously bigger than the build volume. If you wanted to step back, link bigger printer, whatever, how do you go about doing that at scale between printer supers?
Yeah, so we are in the scenario that the printers can't print themselves, so I guess it's not true RepRap and that's about it. But Batch.Works obviously have the fleet printers already at their factory, and in that are large format printers. So you do have this scenario, and we have to make a printer that's bigger than the printer you want to print. But thankfully, that's already covered by the...
Yeah, exactly. And you do need an example of, so we're using some of the rat rates, so some of the large volume ones, at least to get those tactics. But the larger format printed can print that one, so that once we have that, we can start they can start replicating that.
So recently you chose the licensing track forms, and does that limit you in terms of how far you can scale that in terms of before how big a credit fab is?
The what form factor side?
The 19 track form.
No,
this is ourselves from most in 19 twists. Is there anything really joint 9 reps or it's like sort of limitations in terms of when you want to set for a farm for larger printing or something?
I think we've selected that because we've used all our production data to sort of figure out what's the optimal sizes. So this has a build volume of 120, 120, 120 would be 2. And the larger one, basically that allows us to have a bed of 300 by 300. So that gives us good optionality within that.
And the thing with the large user wraps, like they're designed to be easy to put into buildings, move around. There's lots of hardware because for like the Ethernet and the power supply going to all the printers, there's already a market for that, and so utilizing that, there's another reason. And when you're doing thousands of parts, that tends to be smaller things that you automate. If you print like a giant thing, you're less likely to want to push that off into even bigger.
Yeah.
So for when we're targeting these printers itself, it was like a perfect match for using that.
I have a question around specifically the MS one. Like, is it at this point as cost effective to 3D print them than to injection mold these?
Yeah, so that's a really good question. So it's the main point is not just the unit cost. So for them is they are actually 100,000 units worth over 15 months roughly, and as they were refurbishing stores. So for them it's they can order on demand. They don't have to think of storing the tool somewhere. They don't have to have stock in warehouse they have to pay for. So the units is more expensive than it was in modded, but then the whole ecosystem, they just order when they need. And so that for them it's de-risking their supply chain, de-risking restocking when they need it. And also we had scenarios where the Oxford street store, for example, has a special size and a special material, and that's done within days rather than like, oh, we need to plan this so really far ahead. And that's really where we see this changing, and I think we see a similar thing now with AI, where everyone can do software in some ways. I think in the next 5-10 years, everyone's going to be able to make things and using source. So I think we want to try and bring them de-risk complexity of supply chain, to get things down to this. I see price is higher, but it's not drastically much higher, and that's what they're paying. So, and the whole end of life, the fact that we can, after 5 years, we can just collect it back, shred it, and we can make new pricing tickets. That's where circular economy models actually work the same. So
Here. Questions? So that up to all the questions then. Yeah, if anyone has any on this, we'll stop.